Hello YouTube, I am Lulucat's little assistant. Entrusted by Lulucat, today I will introduce a major achievement from his recent hardcore experiments. This is a dungeon exploration game specifically designed for AI agents, Agent Path. To be honest, Lulucat doesn't consider himself a veteran AI developer. Regarding what the trendy AI agents can actually do, or how to build a fun one, he used to be in a state of constant exploration and self-doubt. But Lulucat often says since he isn't an expert at tweaking AI's low-level algorithms, why not use his strengths as a game developer to build a game for AI to play? Thus, this experimental project, aimed at bridging a brain-body decoupling architecture, was born Agent Path. At the very beginning, Lulucat took a bit of a detour. He first tried providing an API in a Unity FPS framework, attempting to let the AI fight in 3D space like a human. But he soon realized that asking current agents to understand complex 3D spatial relations and handle depth and rotation was a bit too much for them. To return to the essence of the experiment, Lulucat decided on a strategic simplification, downscaling to a classic 2D top-down dungeon crawler. He sourced beautiful assets from OpenArt and invited DeepSeek to help design a simple yet complete gameplay loop. Lulucat used Unity to quickly build the game prototype. As you can see, the game interface is very retro and clean, but the most unique part is that Lulucat did not develop a traditional UI or key-based controls for it. Instead, he built a complete RESTful HTTP API service within Unity, supporting fully asynchronous JSON data exchange. This means that from the moment of its creation, this game was never meant for humans. It was meant to be read by code. What you see on the screen now is the agent's entire thinking process. Because of the brain-body decoupling architecture, the player character in Unity is merely a shell receiving instructions. The real brain is hidden within a Python script, running in the background. Please notice the OpenClaw terminal on the side, where various monitoring scripts are running busily. Through the API, the agent is perceiving the level's waypoints, player status, and objective coordinates in real time. In this live demonstration, the agent is rapidly calculating the pathfinding logic for the current level. It calls the interface written by Lulucat to analyze waypoint connectivity, and uses the A algorithm to plan the optimal path through the maze. Once the calculation is complete, the agent instantly sends a movement vector request to the API. Watch closely. The player character in Unity immediately turns and rushes toward the exit. The agent isn't playing the game in the traditional sense. It is acting as a commander, issuing tactical orders via APIs. Lulucat felt that testing only a few levels wouldn't be convincing enough. To test the AI's limits, he developed an automated level importing tool. Using OpenClaw's PCG capabilities, he called the Gemini API to batch produce 200 dungeon levels. Through this tool, all level layouts are instantly converted from JSON data into Unity prefab assets, greatly increasing efficiency. In the final large-scale test, Lulucat found the agent to be very intelligent when handling direct pathing tasks. However, when faced with complex logic, like picking up a key and doubling back to open a door, the agent's decision time significantly increased. Sometimes, it even stops for a while to contemplate the meaning of life. But Lulucat is pleased that the entire API interaction loop and mission cycle are fully operational. This proves his theory. As long as the interface is well designed, AI agents can complete complex tasks in a fully perceptible virtual environment. Of course, Agent Path is just the beginning. Lulucat has already started planning an even grander vision. In future versions, he intends to bring this agent system back to the FPS project, adding true AI agent players. Imagine if we use local YOLO vision recognition for perception, combined with fast decision models. Agents could perform millisecond-level operations and tactics like professional esports players. Eventually, Lulucat even wants to try Agent vs. Agent matches to see who the real AI esports champion is. Lulucat hopes these attempts will show other game developers the new possibilities of AI. If you'd like to let your own agent run through this dungeon, or if you have ideas for this architecture, feel free to leave a comment and chat with Lulucat. I am Lulucat's little assistant. Thanks for watching, and see you in the next experiment.